Hi there, this is your favorite non-Indian math channel, and I have a limit problem with a lot of a's in it. So here, a is not a two-digit. It's not a squared, a times a. It's a two-digit number with like 22, 55, 44. Okay, and so let's see how we can do it. Well, in general, if I have a number like a
2 hours later.
a's. See here I said n times a's, and well, I will have this thing being equal to a times. So from the first digit, it will be only one a. From the second digit, it will be 10 a's, and it's just gonna go up like this. And from the last term, which is gonna be n term, but its n term is giving me n to the 10 to the n minus 1. Okay, cool. Well, I can just do this thing because this is geometric sum, and it's just gonna be 10 a times. So this thing is just increased by 1, 10 to the n minus 1 over 10 minus 1. Okay, cool. So this is in general what a n digit number gives me. And so let's call this top thing, this is the top thing, by a. Yeah, surely there is no enough a, so I used capital A. Well, so if I just rewrite this a, it's gonna be like from the first a, I'm just gonna put, well, for all of these terms, a over 10 to the 10 to the 10 minus 1, which is just a over 9, is common. And then, so from the first term, so only 10 to the n minus 1's change. So if I put n is equal to 1, which is this first number, it's gonna give me 10 minus 1. If I put n is equal to 2, it's gonna be 10 squared minus 1. So it's just going up like this. And for the last term, I'm just putting n is equal to n. Well, it's just same. So it's 10 to the n minus 1. Okay, cool. And now I can just do another geometric sum here. And here, if I look, I'm just adding again 10 to the powers, except this time I'm starting from 10, not just 1. So I can just take it into 10 parentheses. And this is literally same sum. I'm just adding up to 10 to the n minus 1. So it's just going to be the same thing. And I also have minus 1's. And here I of course write, so it's going from 1 to 10, 1 to n. There are n terms, so it's minus n. So this thing is equal to, let's write it, a. So from the first part, it's gonna be a times 10 times. So here I have 81. It's times 10 to the n minus 1. And I have minus an over 9. Okay, cool. So this was a, which is the top part. Let's divide this thing by 10 to the n and take limits. So if I take limits as n goes to infinity, what will I have? So I have this thing, and I'm going to divide it by 10 to the n. A times 10 to the n, 10 over 81, 10 to the n minus 1 over 10 to the n minus, so this is an over 9 times 10 to the n. Well, here, this thing will obviously go to 0. Any polynomial is just growing slower, much slower than exponentials. And therefore, I can just say this thing will just go to 0. I will also make a video about this where I will show you the ratio test for limits. And so for this part, I have 10 to the n and 10 to the n, so they're basically growing with the same rate. I can just take 10 to the n parentheses for both sides. Let's just write it like this. So I have these constants. It doesn't matter. A 10 over 81. This time it's 10 times 10. So it's just, if I just take 10 to the n parentheses for both sides and simplify it, it's going to be 1 minus 1 over 10 to the n and over 1. So it's just same thing. And therefore this thing will of course just go to 0. So it's just 1. Therefore my limit is just going to be 10a over 81. And this is my answer.